Welcome to normalization of database tables. Now, I cannot spell how important this actual topic is because in the long run, as we go through the process of normalizing our database tables, we're really going to be, reducing the amount of work on us in the long run because we're really going to start focusing on minimizing data redundancies and data anomalies, which I'm going to show you plenty of examples on. I think you can figure out redundancies, but anomalies. So think of this. If we have a legitimate item that we're going to need to update relatively often, it would stink that we would have to go through 3 tables, 4 tables, something like that, just to update one item. That's a lot of overhead that can end up having a consistency issue in the long run. So that's what normalization is going to do, is try to eliminate that so that, yes, it may actually mean creating a new table, but it means that we go to one spot that we actually update, one spot that we need to make edits, delete, or whatever, instead of going through a whole bunch of different tables to do the exact same thing. That's trying to knock down all those redundancies. So we're going to revisit data anomalies, but it's really multivariable attributes, which we actually covered before, but we're going to see that as one of our steps in the different forms that we're going to be doing as this process progresses. Our first step is our first normal form, That's where we start off, and then we're hoping to get about the third normal form where we've gotten through a lot of things here that, hey, we've reduced this or we've gotten rid of this. It's almost a checklist, and that's the checklist I'm going to go over with you here in a minute. Now, a third normal form is greater than a first normal form because that basically means the chances of your data redundancy are greatly reduced. There is a fourth normal form. I will go over that a little bit later. It's actually equal to a third normal form. I know, I'll go over that later, but bear with me here. So there is going to be 1 through 4, but 1 through 3 is our biggest target that we're looking for. And again, I'm going to go over each step with you, so they're going to be treated very differently. Matter of fact, the first one in reality is the toughest. Then after that, it gets significantly easier from there. So let's proceed. Just to finish up, from a structural point of view, the higher the normal forms, the better than lower normal forms. Talked about that already. Each time we level up, there is going to be a performance issue. Now, if it doesn't happen all that often, that's negatable. But if we have something that happens often, it's very much like programming, whereas when we're calling a function after a function after a function just to get to somewhere, that's a performance issue. That's actually going to very similarly happen when we do normalization, as we start actually probably adding some extra and smaller tables to make sure that we have the consistency that we really want. That's going to be a performance issue. I am going through more tables. I am searching through more tables just to get the darn thing done. That's a performance issue. So it's going to get the information, but it is going to take time. In denormalization, which I go over literally at the end of all of this, that's if we actually have to bring it back a step and say, look, is it really worth the performance of another table, of all that stuff? It's used quite often that, hey, instead of having another couple of tables, we just shove it back into one again. And I'll explain that a little bit more, but there is that process too, that we actually go backwards because of performance only. So performance does become a part of this as we start breaking things into, maybe adding some things here and there, and then breaking things even into smaller subcategories or subtables.